Hello and welcome, students. My name is Shampa, and today we are going to study the associative property of rational numbers. So let's begin. Let's say there are three rational numbers. Say one of them is 1 by 2, one of them is 3 by 4, and we have 7 by 2. Let us first add 1 by 2 and 3 by 4, and then add 7 by 2 to it. Let's see. Let's add them together. We have got 19 by 4. Now, let's do one thing. We have 1 by 2, 3 by 4, and we have 7 by 2. Let's add 3 by 4 and 7 by 2, and then after the sum is obtained, we will add 1 by 2 to it. Let's see what's going to happen. So, we see that when we grouped 1 by 2 and 3 by 4 together and we added 7 by 2 to it, we got 19 by 4. And when we grouped 3 by 4 and 7 by 2 together and later we added 1 by 2 to it, the result is the same. Now this property is known as the associative property of rational numbers, and we just verified that in case of addition, rational numbers obeys the properties of associativity. That is, if there are more than two rational numbers, you can add them in any order. The result is always going to be the same. Now let's check if subtractions obey the associative property. Let's take the same examples. It's going to be easy. We have 1 by 2, 3 by 4, and 7 by 2. Let's group them first and then we will subtract 7 by 2. We have and we have got, I'm sorry, we have to make the bases same. I'm sorry. Here we have got minus 15 by 4. Now let's do one thing. We will group different members together. And 7 by 2. This time I'll group 3 by 4 and 7 by 2 together. Let's do the operation. See, we have a different result. This was minus 15 by 4 and this is 13 by 4. So we concluded that subtraction does not obey the laws of associative property. Let's see if multiplication and division obeys the property of associativity. Now let's check if multiplication obeys associativity. Let's take the same figures again. We have 1 by 2, 3 by 4 and 7 by 2. Let's group them. We have 3 by 8 into 7 by 2, which is 21 by 16. Now, let's use the same numbers, but we will change the partners. See what's going to happen. This is again going to be 21 by 16. So this is clear that multiplication obeys associativity. You can multiply them in any order. The result is going to be the same. So we concluded addition and multiplication obeys associativity. Now let's check if division of rational numbers, more than two rational numbers, obeys the property of associativity or not. Now let's check if division obeys associativity. Let's take the same numbers. We have 1 by 2, 3 by 4 and 7 by 2. And now let's group 1 by 2 and 3 by 4 together, and we will divide the quotient by 7 by 2 later. Okay, let's begin. We have got 4 by 21. Let's see if we change the order, are we still going to get 4 by 21? We have 1 by 2, 3 by 4 and 7 by 2. Again, we change the partners. So we have 1 by 2 divided by 3 by 14. This is going to be 1 by 2 multiplied by 14 by 3, and it's going to be 7 by 3. So 7 by 3 is not equal to 4 by 21. So we see that subtraction and division does not obey the laws of associativity, whereas addition and multiplications do obey the properties of associativity. So now let us understand, why have we learnt the property of associativity? Is it of any use in mathematics? Yes, very much. Let us understand it with the help of few examples. Now let us understand the application of associative property while we add two or more than two rational numbers. Let's take an example. Let's say we have 7 by 9 plus 19 by 4 plus 2 by 9 plus 5 by 4. Now we have different denominators, so what do we have to do? We will take the LCM, we will make the numerators equal, we will multiply the numerators and denominators to a number so that we get the LCM. Let me tell you, we don't have to do all that. Why? Let's see. First thing is, we know addition obeys the associative property. So we have two numbers with 9 as the denominator. We will group them together, because we can add them in any order and we know the result is going to be the same. And 19 by 4 can be grouped with 5 by 4. So now we have 9 by 9 plus 24 by 4. Let's reduce it to their standard form, and we have got 7. Wasn't it easy? Now let us check the application of associativity with multiplication. Let's see. We have, let's multiply 5 by 6 with 7 by 8 with 36 by 25. So this is the number we have. 5 by 6 into 7 by 8 into 36 by 25 into 64 by 35 into 50 by 96. It's quite a big number, but let's see what we can do. Is it not possible to group 5 by 6 and 36 by 25 together? Let's see. We have 5 by 6 into 36 by 25. Let's group them together. And then we have 7 by 8 into 64 by 35. Let's keep this 50 by 96 separate. You know why we did that? Because seeing this big number, we can conclude one thing. It's a big number, but this denominator is the factor of this numerator, and this numerator is the factor of this denominator. So it's going to make our life easier. So let's do the job. We have 5 here, and 6 and 36 will cancel out. We will be left behind with 6 by 5, and here 7 and 35 will get cancelled. Into 8 by 5 into 50 by 96. Is it not convenient at this point? We can multiply them, or we can do one thing. We have factors here. 8 is a factor of 96. 5 is a factor of 50. And we have 5 by 6. So we have 6 by 5 into 5 by 6. So the answer is 1. Has it not? What we did here in this big number is we selected numbers where we selected the rational numbers where the numerator is a factor of the denominator and denominator is a factor of numerator of some other rational number, or vice versa. Like 7 is a factor of 35, 8 is a factor of 64. Property of associativity says that we can multiply numbers in any order. And that's what we did. It simplified our job. Had it not been so, you would have multiplied 5 and 7 together and then 6 and 8 together. That would have led to the same answer, but steps would have been longer, calculations would have been more, and the purpose of mathematics is to reduce the number of calculations, isn't it? So that's it for this lesson. See you in my next session. Till then, please take care of yourself and have a good day.